All right. Good afternoon, good evening, depending on when you're watching this. So, way long ago, right? You did perfect squares, and you probably haven't heard very much of perfect cubes, but you have seen it. So, if you look down at the bottom of your sheet, right, we have perfect squares, right? All the sides of squares are the same size, and so that's what makes these perfect because every side is the same. And then these, right, are perfect cubes. Instead of just having two sides that are the same, like a square, which is 2D, we have three sides of this that are the same in our 3D. So if you notice, right, the first few are kind of done for you. So we have 1 squared, which is 1 times 1, which equals 1. And then the square root of 1 equals 1. 2 squared, which is 2 times 2, which equals 4. And then we have the square root of 4, which is 2. So if we want to think about, right, like this kind of all goes together, and then this kind of goes together. Okay, so this is getting to this number, and then you take the square root, the inverse, that's what we're going to call that because that's what we're going to do this year, and then you get there. So if you follow along in this same pattern, right, we would have 3 times 3, which is 9, and then this is called a radical or a square root symbol. Okay, and it literally is kind of like your division sign. It just has this little tail at the end. So we have the square root of 9, which equals 3. Okay? So if you would follow through and do the same thing, finish off that table, and then come back. Welcome back. I'm going to do these first because maybe you knew what the multiplication looked like, how to write that, but then you got stuck on what is 4 times 4? What is 5 times 5? Or maybe you knew, those smaller numbers. It was really once you got to like 11 times 11, 121, or maybe it was that 144 of 12 times 12.